So here's an example of that. So when we say M behavior, we have 3x cubed minus 6x plus 1 all over x plus 2. Now when they say M behavior, what they're really saying is, hey, look at this as x approaches infinity. Okay? So can I figure out which graph it is based on M behavior? Well, we said in the last problem, the only thing that really matters are these values, right? None of this matters when we're approaching infinity. Well, if that's the case, then I've got 3x cubed over x. What does that reduce down to? 3x squared.
So then we just graph 3x squared.
Well, we got to look and see if there's something that looks like 3x squared. Which one of these looks like 3x squared?
A.
A. All right. So let's see. Hey, that worked.
So how do you know the limit of x is approaching infinity?
Huh?
Because it said n behavior.
Because it said end behavior. Whenever they talk about end behavior, they're talking about, and what is the ends of a function, graphically speaking? It's when x approaches infinity or negative infinity. Either way, whether I plug in infinity or negative infinity, the graph, it reduces down to 3x squared. That's what it looks like. Now, when we graph the actual graph, it won't look exactly like this. Right? There'll be some stuff going on in the middle. But the end behavior will be the same. What this graph is approaching and what this graph is approaching, the end behavior will be the same. Does that make sense?
Yeah.
Okay.
The function, it's negative infinity to positive.
The stuff in the middle doesn't really matter. What was your question?
Well, when I tried to graph like the entire function,
Mm-hmm.
it started with negative infinity to.
You made a mistake somewhere when you
That's
graphed.
why you only graph 3x squared.
Yeah, I know.
No. What she's saying, first of all, you made a mistake because at no point in time what she's saying is that she graphed it. Let's graph it and I'll show you what's going on. She's saying she graphed it and if you take if you basically if you took the limit as it approached negative infinity, she got negative infinity. So there's probably a typo in your graphing. Like you made some little mistake when you plugged it in. Plus 1.
Did you graph that out and see? Yeah, that's what I got. So, yeah, that's exactly.
Yeah, that's what you get.
That's what I got. Which looks
Yeah,
like C.
but how you said that you only look at the first two. Yeah,
I know, but if you graph the function, shouldn't it also give you
Yeah.
the same thing?
Yeah, exactly. If you're saying if you're saying that for some reason those other terms don't matter, then overall the overall plugging the whole equation should reflect graphing 3x cubed over x.
So one end at the bottom and start from the top. Yeah. 3x
I think what you need to do is you just need to zoom out more. So if we
It's
I
gonna look
tried that,
well,
it's still the.
zooming out isn't gonna do anything because it still is crossing the x-axis, where the other one is just a parabola.
Parallels across it.
Well, I know, but if you look at the parabola that you got before and then versus what's on the graph right now, zooming out isn't gonna make it look different.
Yeah, but what if it went like this?
Yeah, or what if it just looks like that? Hey, look at that.
I want to, how do I,
Take this problem off.
no, because the issue is, if you look at the table of values, okay,
Yeah.
at x equals negative 10, I have 3 times e, see, the table of values show, let me change this, if I look at the table of values, it doesn't even register, right?
Yeah.
So you've got, you're not going far enough in the negative direction for x. Right now, the calculator is calculating that at when x is equal to negative 10,000, y is approaching 3 times 10 to the positive 8. That's a pretty big number. And it's positive. So what's going on, what you guys are looking at, it is negative, but when you zoom out, it's not on the graph in the y direction. So let me do a regular zoom. You have a vertical asymptote that approaches negative infinity, but I would assume that you also have on the other side of that vertical asymptote approaching positive infinity, and it just isn't showing up on your graph. So let's do a standard zoom, and just because it will match up. Now just take a second. Oh man, I did the really big window. Oh.
Interesting.
In other words, what I suspect is happening, if you graph this, I'm going to give that a second for the calculator to process that. You've got some behavior like this, and you're saying, hey, Mr. Adams, look, this is going to infinity. Well, yeah. But this is what you're seeing on your calculator. Okay, this is the window that you see on your calculator. And what I'm guessing is somewhere way up here, you have this behavior. Right? And then also, you probably have this behavior as well. And if that's the case, then what you're going to see is you're going to see some sort of, if you take this, which is approaching positive infinity, and you take this one that goes out and is approaching positive infinity, if you look at the end behavior, it will look just like this. It's just the insides don't match up. But I see some unbelievers. So let's look at this. And
I think you killed it.
Restart
the program.
all right. So let's look at this. We've got that. All right. Let's look at the. Okay, that's what I need to change. So.
Well, that's your table, not your window.
I know.
10 trillion billion.
Okay. So what I want to do is I want to see what goes on. Okay, see how it switches over to positive?
Where?
Knew it.
See this? At x equals, so the vertical asymptote occurs at x equals 2, which makes sense, right?
Yeah.
X cannot equal 2, right? Now watch what happens. Watch this number and watch this number. Right as I cross over to 2.
-2?
Yeah, -2. Sorry. Kind of in a hurry. As soon as I cross over -2, where's my y value?
Oh, dang. Look at that.
See that?
Can you zoom out? So, we can see
So what we got to do is we just got to make sure that we have a y value that fits that. So watch this.
Like 500.
So
Oh, yeah, you're right.
And your calculator.
Oh.
so I'm going to come down here to y
It goes to
min, and I'm going to put 1,000.
Oh, your calculator.
Now watch. Uh-oh.
Oh!
Oh, dang. Oh, dang, look at that.
Now what do you see? You see this going this way and this going this way. Hey, doesn't that look like a parabola?
Oh, it's
Sir.
starting out.
A
Okay.
parable